The last rules for this section are rules for antiderivatives of additions and subtractions of functions. So in the same way that derivatives of sums and differences of functions can be split up into two independent derivatives, antiderivatives of sums and differences of functions can also be split up into separate integrals. And this is a really useful problem-solving technique. A lot of times we want to do this to make the finding of antiderivatives easier. I'll show how it works with this simple example here of f of x equals 2x plus 4. We want to take advantage of the fact that there's an addition in here. And so when we go to find the antiderivative, what we want to do is break it up into two separate integrals. And then we just treat each of them independently, find an antiderivatives for each of them on their own. And then we'll just add the results at the end. So the antiderivative of 2x, according to all the rules we've looked at so far, antiderivative of 2x will become 2 times x squared over 2. Okay, and then over here we want to find the antiderivative of 4. And according to rules we had looked at in the past, that would become 4x. And all we have to do is just put a plus between them. And we need a plus c at the end. So I'll simplify it just a little bit, cancel these 2's. And my final answer then will become x squared plus 4x plus c. Go ahead and try the next one. Okay, the first thing I'm going to do is put an integral sign out front. And a dx at the end. We got three terms separated by subtraction and addition. What we want to do is break them up into three separate entities and take the antiderivative of each. And then put those signs between them. Alright, so we're going to get 3e to the x for that one. Negative x cubed over 3 for the middle one. And this e is actually just a constant, so we'll have e times x as our last antiderivative. And we have to put a c at the end. And that's the answer.